current electricity. This is our second lesson on potential difference or voltage. They're both the same, mean the same thing. And what they do mean is that for each coulomb of charge, you might remember a coulomb of charge is like I'm sort of lying to say a packet of electrons, but it represents a certain number of electrons. It's how much energy they have, right? And that's an important deal because the more energy they have, the more light you can get, the more current you'll have, the more, I don't know, whatever it is you're trying to do, the louder the bell you want to ring or whatever it is you want, you can do more of it. Or maybe you don't want that much energy. It's the other thing. So understanding what I mean by that, this is it's something that some of you might get, some of you won't, but imagine you've got a circuit, and just look, bring your eye over to the right here. I've got a 9-volt battery, so I'm adding 9 volts to the circuit, right? The electrons come out of the short end of my battery. They go through, in this case, a light bulb. They come down, they go to another light bulb, and then they come back to the battery. And the idea is that, sort of the rate, how fast they move, never changes. 2 amps the whole time, if that's what it happens to be, right? It's not going to slow down at any point in the circuit, because if they slow down, say they slow down right here, well, it's sort of like the electrons would all bump into each other. Imagine liquid flow through a circuit, right? It all go at the same pace if you had a sort of series of pipes. It's not like the water current would go faster at one point than the other, right? So they go at the same rate. But what happens is, and I'm being simplistic to say they use the same amount, but say the first bulb uses 4.5 volts. I have a 9-volt battery. Say the first bulb uses half of it. Well, the second bulb would use the other half because what comes back is nothing. And then every electron gets added an extra 9 volts of energy. So the same electrons move through the circuit. They don't go anywhere, right? But it's like they have a certain amount of energy, then they lose energy after the first bulb, and then they lose the rest of it. And then it all gets added back to them. And so what this is supposed to show is saying, think of it as, gravitational potential energy. You have nothing, say they got no energy coming into the battery lifts them way up, and then as soon as they hit the first bulb, they drop a certain amount, hit the second bulb, they drop the rest. Okay, so the energy, which is the voltage, sort of drops as you go through the circuit. The rate stays the same, excuse me, but the amount of energy they have doesn't. If you hear the term voltage or you hear the term potential difference, they mean the same thing. So just some details as far as calculations. We give the symbol volts for voltage, so V, which is easy, and the units, V, easy. The formula is voltage equals energy divided by charge, because it's energy per unit charge. So if you're given energy in joules, which always energy is joules, and then charge is coulombs, you could say that not only is voltage measured in volts, but it is also measured in joules per coulombs. So sometimes you'll see this. Like I said, you won't see 9 volts, you might see 9 joules per coulomb, and it means the same thing. Okay? Just a little example. A light bulb emits 12,000 joules of light and heat with 100 coulombs of charge. Determine the potential difference. It's a straight divide. Okay? Energy divided by charge. Again, the hardest part is just deciding what's what in here. And then you just sub it to the formula. Excuse me. You can combine formulas. So here's another one you might want to write down on write these all on your formula sheet, right? And what I'm doing here is I'm just saying Q from our last unit is just I times T, or our last note. And so it gives you another formula you can use. And you'll see if you do some of the problems, you'll be using that formula. When measuring potential difference, you might remember this from grade 9, but if not, I will be here to remind you. You set up your circuit, and say you want to measure the potential difference around one of the motors in this case. I have 3 motors in my circuit and a battery, and I want to measure the potential, how much energy is used on this motor. You just take the meter and you touch the leads, right? Just on some metal on either side of the motor, and it'll actually measure the difference in energy, which is what you want. It's how much energy does that motor use, right? And that's how you do it. So again, a nice easy lab to do. It's a good practice measuring everything. It takes you like 15 minutes. It's a good one. Okay, so I would suggest you do that second lab for the unit on, you don't have to, but And also the calculations are actually pretty easy in this part as well, so well worth doing.